Hello, welcome to Mytechfun. Eibos sent me their newest filament dryer for the testing. I already tested at least 10 filament dryers on this channel, and one of the best, actually with the best drying capabilities is this, one of their previous versions, the Cyclopes. It is really able to dry even the nylon. It can heat up the air inside up to 70 degrees Celsius. Just few words, why do you need a filament dryer? Well, filaments will absorb moisture from the air, and by time this has a very negative effect to the print quality. Some filaments are more sensitive to this, and the most sensitive is the nylon. So definitely the nylon, even the printing I'm doing from the filament dryer. But it also requires higher drying temperatures, at least 70 degrees Celsius. All other filaments depend on the type, of course, can be dried on 55 degrees Celsius, 50 degrees Celsius. Some other filament types which are also sensitive to this are PETG and even TPU. I have some TPU filament testing in progress, and you will see in a few days it will be published. Huge difference in the print quality if I dry it only 4 hours on 55 degrees Celsius. Now this filament dryer is Polyphemus, and it is also able to dry even the nylon. It can heat up the air up to 70 degrees Celsius. It has some preset values, different power levels, and it uses the hot air drying method. So it has also some new features like automatic rotation function of the spool, and I think this is important because very often when I'm drying some filament, I am rotating it every hour or something like that to have the more equal drying before the printing. And once actually I noticed this, I placed the filament into dryer. I dried there, I don't know, 3 hours or something like that, and the dryer was much stronger from the bottom. And when I was printing, I noticed some lines in the printing, and actually later I realized that nicer lines I got when it was the dry side, and when the filament rotates to the still wet side, that line or part of the printing was not so nice. What I don't like with this version that it is loud, and especially if you set some lower temperatures, it is quite annoying. I can even hear some mechanical relay which turns on and off the fan every maybe 20 seconds or something like that. And here in specification I can see that they are using some silent fan, and I hope they included that suggestion which I had for this printer, that use some fan where they can reduce the rotation too, not just turn on and off, and with this it can operate much quieter. Additionally, also it has some automatic humidity control, so we can set the desired humidity, and it turns off the heating, and it will turn on the heating only when that humidity will be above some set value. Now about my testing method. Yes, I could do some printing and then dry the filament and reprint that part and to see the difference, but I like some testing method which is comparable, and I have my testing method where I am drying that sponge. I place exactly 2 milliliters of water in it, and I will dry it 1 hour, and constantly I'm measuring the temperature and humidity inside, and I can measure the weight of the sponge at the end of this test. And with this the results are more or less comparable with those which I did in earlier videos and other filament dryers. One more thing I want to mention, this is still some kind of prototype, and for example this expansion kit arrived separately out of the box, but I think it will be included here. This is expansion kit if you want to use 3 kg spools too, then we can raise it a little bit because it can fit inside them. But I think in future packaging this will be inside this box. Little bit off topic, I got this package a few months ago as a gift, and they told me I don't have to create a video about it, so I just want shortly to mention. And a very interesting package here, 5 filaments with very interesting colors inspired by Morandi color palette, and this makes a great choice for the artist too. I'm not really sure what Morandi color palette is, but definitely these are very interesting color filaments. Okay, I think it's time to see what's in the box. The packaging is good. Only I noticed 2 legs fall down, so I just glue them back. And then I'm removing the protection foil from the acrylic glasses. This is the content of the package, and unlike the older version, the Cyclopes, where we have this acrylic cover in one piece, here we have to assemble it. This is the top cover, and as you can see we have some openings for the filament, but we have some plugs in the package so we can close it. And also there is another big opening here, which can be opened or closed. And there is a warning, so do not close the air outlet when drying. So for the drying, definitely this has to be open, so it will let the moisture go out of the box. And you can use this as a storing of the filament, then you have to close it. Let's take a closer look of the base. So interesting, here we have slots for the desiccant. And also it can be used here as an exit for the filament. These are rollers. There is a sensor, and this is the screen. I will talk about it later when I turn it on. And on the back side we have input for the power. This is a spare DC motor for the rotating of the spool. It has only 2 wires. And this must be some box gear reduction to reduce the RPM. And what I'm worried about, that according to user manual, it says that a lifetime is only 1,500 hours. And it goes inside here. This is a speed up time-lapse video of assembling the cover. And for this I needed approximately 5 minutes. Last step is installing the handle. I'm just curious about your opinion, which design you think it is better. These are plugs for this hole, and I like the idea that it can be used as a dry storage box, but these don't have a sealing line. Even if I close this opening, I can still see some minimal gap, and also I can see some gaps here. So I think this should be used primarily as a dryer, not as a storage box. For that, I suggest you to, take out the filament and place in some kind of vacuum bags with some desiccant inside. The power cable is 1.5 meters long. I will place a spool inside so you can see it's rotating. Let's turn it on. And for the first feeling, it is not loud, quite quiet. Let's see the display. So this is the current temperature, this is the remaining time, this is the set temperature, relative humidity. These are the level modes, and that's it. Okay, let's see. This is the option button, and with this we can change the preset values. I will go back to PLA. And then with the settings, we can change the set temperature or some other settings, the level or remaining time for this preset value, if you want to change the default settings. And long press of these settings, we can switch between Celsius and Fahrenheit. Now it is in Fahrenheit. Let's go back to the Celsius. Fine. With this button I can enable the rotating of the spool, so it will slowly rotate it after every couple of seconds, and this will result more equal drying. I will turn it off. By pressing the off button, it will go to sleep mode, only relative humidity is visible here, and one more press, it will turn off. I noticed the fan will turn off after 1 minute, so that's normal. If you change those preset values, a long press of this off button and it will reset the factory settings. But everything is nicely explained in this user manual. It's time to start the experiment. I decided to include the Cyclopes here too, and then we have some direct comparison. There is the DHT22 humidity and temperature sensor, and data will be recorded with this Arduino Uno. I will record the temperature and humidity every 10 seconds. I will measure these sponges. These are cleaning sponge for the soldering iron. I will measure their weight, then I will add 2 milliliters of water, but I will measure the weight of the water too because it's more accurate. And now I will start the drying, and I will measure the sponge after half hours and after 1 hour. This is again a time-lapse video. This is preparing the first sponge, which will go inside the Polyphemus. And this is the second sponge, and this will be going inside the Cyclopes. Now I will start the drying on the maximal temperature. Resetting the serial output, and I'm collecting the data from now. Again, you can see my test setup. I really try to create a similar circumstances here, so the sensor and the sponge is approximately on the same position in both dryers. And even on the screen I can see the current temperature and the humidity inside. But I'm collecting the data with this Arduino Uno, and this is the serial output, and I will analyze this later in the Excel table. Oh, test is in progress, 6 minutes passed, and now I notice that I forgot to add some silica gel here. I don't have time to open these containers to insert the silica gel, but I believe the effect will be the same. And I know with this the comparison will not be fair between these two dryers, but since we have here the dedicated space for the silica gel and the Cyclopes we don't have, this is how the user should use it. And maybe it's not a fair comparison, but realistic. One more important difference between two dryers. On Cyclopes we have the exit of the hot air in the center, and it goes on the top through these holes. On Polyphemus it goes to the back side over these silica gel containers, and it goes in these circles, and that's why we have the sensor here. And I believe that this will result more equal drying, even if we don't use that spool rotary. Also, I noticed the air blowing on this old dryer is stronger here on the exit, maybe because it is blowing directly up compared to this one. Maybe I can illustrate you with this piece of paper. So as you can see, it don't want to stay above this hose. And if I place it here, it almost stays in one place. After approximately 22 minutes, the temperature inside the dryers are very similar according to my sensor. 55 and 57 degrees Celsius. Now there is a big difference between the sensor on the dryer. It shows 70.6 degrees Celsius. Of course, I understand they are on the different position, but this is quite big difference, and I'm not sure if it will continue with the heating. It's time for the 30-minute measuring. Even for the filling, the sponge from the Cyclopes looks much drier, but I will show you the results later in this video. And it's time for the 1 hour measuring, and interesting, quite big difference in the temperatures inside two dryers, but let's measure the sponges. I will show you the results and analyze the graph later in this video. For the filling, both sponges are completely dried. This one is even lighter before the experimenting because it has some moisture from the environment. But yes, definitely very similar. Both dryers are quite good, but the Cyclope is slightly better. I'm still collecting the data because I want to record some cooling process maybe next 10 minutes. One more quick test. I turned them on, and after 20 minutes approximately I want to see what will be the temperature if I measure it exactly where their sensor is. So this is the sensor on Polyphemus, and this is the sensor on the Cyclopes. After approximately half hours, let's check the temperatures. According to their sensor, 71.4 degrees Celsius is inside, and according to my sensor, 69.3, so very accurate measuring in both cases. Now in the Cyclops, it's still raising. After half hours it didn't stabilize completely, 62.7, but of course the sensors are on different positions, so here we have them on few centimeters high. One more thing I want to measure with the Cyclops, and that's the temperature of the hot air which comes from the inside. And now both sensors are measuring directly the temperature of the hot air, which is quite similar. So on the Cyclopes it is 70.1 degrees Celsius only after a few minutes, and on the Polyphemus it is 68.4 degrees Celsius, which is very close to the set 70 degrees Celsius. I can now stop the experiments and analyze the data. And it's time to analyze the data. And these are the temperatures, and don't forget the sensors were approximately on the same position in both cases. And here actually I can see that the Cyclops was better in this case. Now I can see on Polyphemus that here approximately after 20 minutes it started with turning on and off the heating. I believe that it reached the desired relative humidity, and then according to their website they saved some energy by turning on and off the heater. And here actually I turned it off and recording some cooling data. Now let's see the relative humidity. Both act very similarly. In this case, the Cyclops was again just a slightly better, but approximately below 15% of the relative humidity it stabilizes, and here it was turned off, and here we can see that the relative humidity started with the rising. Now then I move the sensors next to the sensor of the dryer, and here we can see the temperature of the Cyclops, which is approximately on 40 or 50 millimeters above that base. On Polyphemus it reached after 5 minutes the desired temperature, so this was exactly where the hot air goes in, and here it started with the turning on and off the heater. And then here I move the sensor exactly to measure the hot air, and here we can see that then it reached this 70 degrees Celsius, even higher. And something similar we can see on the relative humidity. So this is the relative humidity of the Polyphemus, below 10%, which is great actually. And on a Cyclopes, don't forget here the sensor was higher, and when I move the sensor exactly to measure the hot air, then I can see some decrease in relative humidity. Probably it will stabilize around 10%, which is also great. And then measuring that sponge, well, here actually the Cyclopes performed much better. So after half hours it removed 80% of the water compared to 56% of the Polyphemus. Now maybe the sponge was closer to the moving hot air, I'm not sure, but the sensors were on same position, and here also the Cyclopes performed better. After 1 hour in both cases the complete water was removed from it. On the Cyclopes even more, because probably it had some moisture from the environment. I'll try to check how equal is the drying with this thermal camera after approximately 5 or 10 minutes. And here I will use the spool rotating function too. Now let's analyze the surface temperature after 10 minutes of drying. This is the Cyclopes, and let's analyze the spool, and I can see huge difference in the temperature on two sides of the spool. And then this is the Polyphemus, and the temperature is much more equal. I believe that it will be more equal even if I don't have that rotating of the spool. And maybe it doesn't look significant, but it is very important to have equal drying of the spool. Now the conclusions, and important to clear one thing, and that's drying of filament is a little bit different compared to the drying of sponge, but this is some kind of test which I could repeat with the other filament dryers too. The drying has two stages. First we need a high temperature to force that moisture to the surface of the filament, and then we need a drier environment, and then that water will evaporate from the surface. And in this, these both dryers are quite good. I have the feeling that the old dryer is stronger for the drying compared to the new one, a little bit higher air temperature, higher flow rate of that air, but I think that the new one is still better because of four important features. First of all, on new one, the hot air goes from the center, so if you don't place the spool on the center but on the two sides, drying will be better from the inner half. Here, the flow of the air is more equal. Additionally, we have that rotating of the spool, which would be much more important with this version here. Third one, for me it is very important that it is quieter compared to this one, not so annoying even if it is in the same room where I'm working currently. And the fourth one is that we have the dedicated space for the silica gel, and actually it will be in the way of that moving air, so it will help to keep it dry. This is my experience with this new filament dryer from the Eibos. Both are great and both are able to dry the nylon too. They work a little bit different. Don't forget, with this one you need to rotate the spool from time to time because it will get a very strong air from the bottom, but to have more equal drying you have to rotate it maybe just a little bit after every half hours or something like that. If you have some other experience, or maybe you have some better filament dryers, if you want me to test it, write me a few lines in the comment section. Thank you for watching and happy printing!